Hi guys, welcome back to Intellify. My name is Navya and today we will do NCERT solutions of Relations and Functions Chapter 1 of Mathematics Class 12th Miscellaneous Exercise question number 2. So the question is, let f be from W to W be defined as Fn is equals to n minus 1 if n is odd and Fn is equals to n plus 1 if n is even. Show that f is invertible. Find the inverse of f. And here W is the set of whole numbers. So the solution is f defined from W to W be defined as Fn equals to n minus 1 if n is odd and Fn equals to n plus 1 is if n is even. So we can say that Fn is equals to Fn minus 1 if n is odd and n plus 1 if n is even. So f is invertible if f is 1 1 and onto. So for 1 1 there are three cases. For any n and m, two real numbers, let's say. So case 1 will be n and m both are odd. So Fn is equals to n plus 1 and Fm is equals to m plus 1. So if Fn is equals to Fm, so n plus 1 is equals to m plus 1, which implies n is equals to m. Now case 2 is n and m both are even. So Fn is equals to n minus 1 and Fm is equals to m minus 1. So if Fn is equals to Fm, n minus 1 is equals to m minus 1, which implies n is equals to m. Now case 3 is n is odd and m is even. So Fn is equals to n plus 1 and Fm is equals to m minus 1. So if Fn is equals to Fm, m minus n is equals to 2, which is not true because even minus odd is equals to even, therefore f is 1 1. Now we will check for onto. So Fn is equals to n minus 1 if n is odd and n plus 1 if n is even. So say Fn is equals to y and y belongs to w. So case 1 will be if n is odd. So Fn is equals to n minus 1, which shows if n is odd, y is a even number, y is an even number. And case 2 will be if n is even. So Fn is equals to n plus 1 or n is equals to y minus 1. If n is even, then y is odd. So in any of the cases, y and n are whole numbers. So this shows f is onto. So again, for inverse of f, since we got f as 1 1 as onto, so we can now find out the inverse. So for inverse of f, f inverse is equals to n minus 1 for n is equals to y plus 1 and y is equals to n plus 1, which implies n is equals to y minus 1. So Fn is equals to n minus 1 if n is odd and Fn plus 1 if n is even. Therefore, F inverse y is equals to y. This shows the inverse of f is f itself. Thank you.